welcome back my dear friends and students. This is the 17th lecture for the TQM2 under the NPTEL MOOC, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. Very good morning, good afternoon, good evening to all of you. Now, if you remember in the 15th fag end of the 15th lecture and starting of the 16th lecture, we were discussing about factorial designs, in the sense the relationship between factors to the levels of which their dependence structure is, and based on that we will basically have a dependence model. Now, the word dependence I am using in the very general sense, dependence model such that we are able to predict or find out the average relationship average. Because why I am using the average, please give me a few minutes, I will come back to that. We want to find the average relationship between the independent variables and the dependent variables. Now, if they are related, the independent variables are related, and if there are two factors, obviously you will have the effect of x1, effect of x2 taken separately, then combined x1 and x2. And if there are more than 3, obviously it will increase proportionally, like first individually all of them, then taken 2 at a time, then taken 3 at a time, and so on and so forth. Now, why I use the word concept of average is that if you remember, there is an error term which is very important, and we assume the error term has a normal distribution with a 0 mean and a standard deviation which is fixed. It can be 1, it can be sigma square, and the fact that it is fixed, that it means that it does not depend on time. So, those things, as I took your kind permission, I will be repeating it time and again to make it much clearer to you. And then we also considered later on in the 16th lecture that depending on the factors, the interrelationship, the efficiencies concept would also be considered, and how we can find out if there are linear relationship that on a 3-dimensional scale. Consider you are in a room, and the vertical axis would be basically measuring the y values, and the horizontal axes which are along the breadth and the length of the room would basically be x1 and x2, considering there are two different variables of x1 and x2, and the linear relationship would be given by the planes which are cutting. In what direction they are, that would depend on what are the values of so called beta 1, beta 2, beta 1, 2 and all these, and beta naught obviously, as I mentioned, would be the conceptual values of c which we have when you are trying to basically draw the curve y is equal to mx plus c. And if you see the plan from the top and considering y values are not changing, then you can find out the relationship between x1 and x2 if there are only two variables, and if they are on the higher dimensions, considering x1, x2, x3 are there, you will have hyperplanes. So, with this we will start with the 17th lecture. So, now if you remember, we are trying to basically study the concepts of interrelationship of the example. I am coming back to the example, the discussion further on. There were batteries, and batteries operated at different temperatures. The temperatures were such that you want to find out what is the effect the temperature difference has on the battery operation, and we found out the relationship between the temperatures and the different levels of independent structures which were there. And in order to make life simple for us, I did mention that there would be 3 variables or nomenclature of trying to basically specify the variables. One was I, one was j, one was k. I changed from I1 to small a, which was factor for factor a. J changed from 1 to small b, which was for factor b, and k was basically the number of samples which you had for each group, which was basically from 1 to small n. Hence, the total number of observation which you had was small a into small b into small n. And we also found out that what was basically the averages of the averages of the averages. So, and I am using the word averages 3 times, which means that I am basically trying to find out the sum for all the a's, or all i's, sorry, for all the j's and all the k's. And then obviously you will have different nomenclature to denote y bar dot j dot. That means you took the averages for i's and the k's, keeping j fixed. Then you also had the average of y bar I dot dot, that means you took the averages for all the j's and all the k's, keeping I as fixed, and so on and so forth. So, if it was average of the average of the average, which was technically the population was value was mean mu, then obviously you had y bar dot dot dot, such that you basically dot 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 I am using for the suffixes, you took the averages for all the three ranges of I, j and k. So, concerning that, we found out that how we can find out the total errors divided into three different what I should use the word, three different concepts of influences, which means there was some total sum of the square of the errors. There would be interrelationship, inter and intra, in order to make the things understand. One would be along the i's, one will be along the j's, and one would be the corresponding the relationship between I and the j. Now, once you find out the total errors, obviously your next task would be to find out the degrees of freedom, and the degrees of freedom was mentioned very categorically. So, in one case it would be a minus 1, another case would be b minus 1. This a and b are small a's and b's, and another case it would be a into b, small a into b in the bracket small n minus 1. So, with this we want to basically go into the concept of finding out the average error. So, this is what we are going to discuss now in the slide. So, within each of the A into B cells, there are n minus 1 degrees of freedom between the n replicates. So, basically you had m replicas on n sample size which was there. So, thus there are A, B into bracket n minus 1 degrees of freedom for the errors. So, which I did mention that few minutes back. So, each sum of the squares divided by its degree of freedom is basically the mean square. The expected value of the mean squares are to be found out, because that will give an average error. So, those values are as given here. So, I will try to highlight it using different highlighting color in order to make the differentiation much more clear and stark for you. So, this is so let me mark it. So, this one is the expected value of the mean square of the errors corresponding to factor A, because the suffix A is there. So, you had SS suffix A was the sum of the square of the errors corresponding to factor A, and what was the degrees of freedom? Degrees of freedom was small a minus 1. Here you find small a minus 1. So, that overall error comes out to be sigma square, if you remember, was the errors variance, which was constant. And if you remember the tau, where I am hovering my this pointer is tau i's, was corresponding to the deviations from the actual average for each and every I values, or we can have tau 1, tau 2, tau 3 till tau a. So, that was tau I square summed up for all the values from I is equal to 1 to a, divided by obviously degrees of freedom was a minus 1, and multiplied by b into n, because they would basically have such values for b number of readings for factor b, capital B, and each being each of the combinations of cells of A and B. Cells means the combination of A and B factors which were there, you would basically have such n small n number of replicates. Similarly, when I try to find out the mean square for the case for factor B, so that is given by m as mean square suffix b. So, suffix would basically make things clearer to you, and if I want to find out the average of that, that it would be the sum of the squares corresponding to b. That is why it is the suffix b is here, where I am trying to basically highlight now, divided by the degrees of freedom, which is small b minus a. Again, this will come out to be sigma square plus, now there is a very nice relationship which is coming out. In the other case for the small deviations or so called dispersion, again dispersion being used in a general sense with respect to the mean value mu, for the case when you are trying to find out the effect of the factors capital A, you had tau i's, I is equal to 1 to a. Now, when you are trying to basically, so that was along the rows, so A's was along the rows. When I am considering along the columns, which is capital B, starting from j is equal to 1 to small b, then obviously the so called dispersion concept was brought up by the by using the variable or the symbol beta suffix j. So, you will basically find out beta suffix j square. Square is because you are trying to, okay, I did not mention the squares over the taus or the squares over the betas. Basically, they are considering that you are assuming some of the squares. That means, you are trying to find out the deviations, squaring it up and basically summing it up as you do for the variances part. So, you had a into n for all the other replicates. So, for the factors a and for the n number of replicates which you have, and multiplied by summation of beta j squares for j is equal to 1 to small b and divided by the degrees of freedom, which as we all know is small b minus 1. When I want to find out the interrelationship errors, so it means factors of a and b combined, the actual value comes out to be again very simple logic is coming out. Again it is I will use a different color, let me use green. So, this would be ms, which is mean squared suffix ab for the combinations, and here SSAB, which is sum of the squares suffix AB, divided by what is the degrees of freedom, that would be along the rows, if you consider, they would be a minus 1 because you are losing 1 degrees of freedom for that, and along the columns would be small b minus 1. So, the degrees of freedom for both of them would, and to find out the so called expected value would be for the case when you divide by the term a minus 1 into b minus 1, as it is pointed out where I am hovering my pen. And the overall mean squared average values basically become sigma square is already there. Now, you have to add some terms. In this case, it will be n, because n replicates are there, multiplied by double summation of I is equal to 1 to small a and j is equal to 1 to small b. Now, if you remember, the overall dispersion of the errors which are coming out due to combination of the factors was given by the term tau into b suffix ij. So, this is and obviously it will be squared because you are trying to find the sum of the squares. So, that will be tau b suffix ij square, and obviously the division would always remain the same. Now, in this case it is a minus 1 into b minus 1, and finally, the mean square of the errors would basically be sigma square, as we have found out in the general case. We can prove it very simply. Now, what we need to find out is basically the ratios of the mean squares would give me the values of the F distribution. So, what are the ratios of the mean square? Would be mean square for factor A divided by mean square of the errors. Another would be basically the mean square of factor B divided by mean square of the errors, and another would be the mean square of the combination of the errors of A and B divided by the mean square of the errors. So, they would be distributed as f with degrees of freedom corresponding to the fact respectively they are small a minus 1, small b minus 1 and a minus 1 into b minus 1. So, this is what we just saw in the numerators. So, these values would be there in the numerator to give you the concept that what is the degrees of freedom. And if I find out the degrees of freedom corresponding to the terms which is basically the error, so that error term would basically be coming out, wait, let me check. Yes, the error term for the degrees of freedom for the error would basically be, if you remember, I did mention small a into small b in the bracket n minus 1. So, the test procedures is usually summarized in an analysis of variance chart as shown in table 5.3. So, what are those? I will just explain. The sources of variations due to the factors which are coming out would be given in the first column. So, here you would basically have due to factor A or treatment A first, due to, then the second one would be due to factor B, which is the second, third would be the interaction, that is A into B, fourth one was basically the errors, and the fifth one would basically be the sum. Now, if I change the scenario, I will come to the second, third, fourth columns respectively later on, but let me expand the thought process and try to find out if there are three factors. So, one would basically be the overall effect due to treatment A, consider factor A. Next would be, I am going along the columns for the hypothetical thought out example which I am considering. Second will be for factor B, third will be for factor C. Then we will come into the combinations of what are these? Factor A into B, factor A into C, factor B into C. And the last one for those combination would be the factors A, B, C combined together. And obviously, the second last one would basically be for the errors, and if you sum up all the errors, it will be the total sum of squares for the whole problem which you are discussing. Now, they would basically have the sum of the errors, which will be, for this hypothetical thought out example, would be denoted by, now I will mention SS and with the suffixes. It will be SS suffix A, SS suffix B, SS suffix C, SS suffix AB, SS suffix AC, SS suffix BC, SS suffix the errors, and SS suffix T, which is the total. Now, if you consider the total degrees of freedom, it would be found out accordingly. So, in the cases, if there are A, B, C, small a, small b and small c, they would be found out accordingly, which would be basically A minus 1, B minus 1, C minus 1. Then for the two combinations, it will be A minus 1 into B minus 1 for A and B, A minus 1 into C minus 1 for A into C, and B minus 1 into C minus 1 for B into C. And the last one, when you are trying to combine all of them, would basically be given by the interaction would be A minus 1 into B minus 1 into C minus 1. And if I consider the total, the degrees of freedom would be A into B into C into N minus 1, and obviously you can find out the errors according to the degrees of freedom accordingly. Now, if you come to the mean square, so the values which I just mentioned was for the thought out example if there are 3 factors. So, now when I am repeating, it will make sense if you look at the slide which is there being shown. Now, when I want to find out the mean square, obviously it will be the sum of the squares divided by the degree of freedom. Degrees of freedom, as I mentioned, for the 3 factors would be, first 3 would be A minus 1, B minus 1, C minus 1, and for the combinations you can find out and proceed accordingly. Similarly, you find out the f values corresponding to factor A would be MSA suffix A divided by MSE. Then for the second case, it would be MS suffix B divided by MX suffix E. For the third case, it will be MS suffix C divided by MS suffix E. And for the other three combinations taken 2 at a time would be MS suffix AB in one case. In the second case, it will be a combination of AC, and the third case it will be BC. And division would always remain as the case which I mentioned would be the mean square of the errors, and similarly you can find out the f values for the combinations and the errors and basically proceed accordingly. So, one can write, if you remember the ANOVA actual identity model as, so now there would be differences of each individual cell values with the average of the average of the average for this case. So, it will be y suffix I j k minus y bar dot dot dot, because you are summing up for all i's, all j's and all k's, and that would be the combination of the differences of the errors in this front. Number 1, I will highlight and mention. The first one is basically when you are summing up for all the j's and k's keeping i's as fixed. So, that would be the first term minus y bar dot dot dot. Third one would be, second one would basically be when you are trying to find out the sum of for all the i's and all the k's keeping j as fixed. So, which is here. So, I will use a different color to make it interesting and much. So, this one. The next two terms, if I consider, would basically be, okay, I will come to the last term first with a different color. So, it would be again y I j k for each cell minus the sum of for all the n values keeping I and j interchangeably changing from 1 to A and j changing from 1 to B, small b. And the third value, this would basically be the differences of the sums taken for I j dot, that means summing up for all the n's, and y bar dot dot dot, that is for all the summed up for I j and k, and the values which will be subtracted would be those combinations which you have already taken on the left hand side, that is for the red and the orange. That means you are finding out the values using the plus values for what? Those are y I dot dot, second one is y bar is obviously there, y bar dot j dot. So, they have to be negated. So, those values would be coming with a negative sign in order to balance the whole equation. The total sum of errors would be very simply found out by finding out the square of the errors. So, that would basically in the end come out to be y square dot 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 divided by a, b and n, because that is the total number of observations. So, the sum of the squares for the main effect can be found out from a and b, and or it can be extended to a, b, c, and you can do the calculations accordingly. It is convenient to obtain the sum of the squares of a, b in two stages. First, we compute the sum of the squares between the a, b cells in total, which is called the sum of the squares due to the subtotals, and then basically go into finding out the averages of the subtotals totally. So, the subtotals would be, if you pay attention to the formula, these things would become very clear. So, what is the formula? Again I will highlight. So, with the blue one, or let me change the color because it is becoming too dark. So, this is one. So, that will be y square I j dot, that means you are summing up for all the n's. Obviously, in the denominator it will be divided by n as it is here, which I am just highlighting again with the same highlighted color, but other to make it understand. And the summations, as you know, would be basically be for all the values of keeping I and j. So, obviously, it will change for each and I and j. So, it will be summed up from I is equal to 1 to a and j is equal to 1 to b. This sum of the squares also contains the SSA and SSB. That means, the SSAB is being basically taking as in a much more broader sense to it. If you look deep into the sum of the squares, you will have basically the values of a and b. Therefore, the second step is computing is to compute SSAB as, now what are these? SSAB would basically be the sum of the subtotals minus, so it is like this. I will try to explain. So, when you consider this is a Venn diagram and you want to find out the probability for, so there are events A, B, C. So, this A, B, C and the A, B, C which is being mentioned for the factorial design problems are different. So, they are just events A, B, C which I have drawn. So, when I want to find out the total probability, what I do is that I find out the probability of A plus probability of B plus probability of C minus the intersection of A and B minus the intersection of B and C minus the intersection of A and C. Then as you have subtracted, so obviously you will add up A intersection B intersection C. So, this if you consider there in the problem, there you will find out. So, sum of the squares of AB would be subtotals, which is already considered the A and B once. So, you will basically divide or minus the values of sum of squares of A separately, sum of squares of B separately, and find out the sum of the squares for A and B taken together. We may compute the sum of the squares for the errors by subtracting this. So, the sum of the square of what is the errors? Errors is basically the difference of the total minus the individual effects of the errors, which is the sum of the squares which is coming up from all the cases. So, what are these? One would be for A separately, no effect of B or no effect of A B combined. One would be the effect of B for no effect of A and no effect of A B combined, and last one would be the effect of A B combined with no effect of A or no effect of B taken individually. So, this would basically the formula. So, you can find out. So, if I basically find out, so the sum of the errors would be the total errors minus the SS subtotals. Now, if I go one level higher, A, B, C, you will find out in that case the subtotals can be considered in a similar way, where they would be effects on A, B, C, and then you have to basically subtract the effect of A, B, A, C and B, C and go in the same logical sequence as we just discussed. So, I have considered this example. So, this 5.4 table represents the effective life in hours observed in the battery design example. The row and the columns are shown in the margins of the tables, and the circle numbers are the cell totals. So, basically a material type A, A's are given, and these are the temperatures. If you remember in Fahrenheit was 50, 15, 70 and 125. So, for the material type 1, for 2 and 3, the values are given as 130, 155. So, this I am reading. and just mark it with okay, let me use the red one. 130, 155, 74 and 180. So, if you add it up, 5 plus 4 9, so here is 9, 5 plus 8 13, 20 23 3, 2 2 1 3 4 and 5. So, this is 539 which you have the total. If I add up for the material type 2, the add total comes out to be 623. If I try to find out for material 3, it comes out to be 576. So, and then the total value is 1738 for temperature being fixed, which is 15, and for all the 3 different materials. Similarly, you have 228, 479, 583 for temperature of 70. Total value for all the combinations is 1291, and for the last degree, the last change in the temperature, which is 125, the values for the total sample size for material type 1, 2, 3 are respective 230, 198, 342, and the total value is 780. So, if I find out the sum along the margins, which is the last column, so this 998 means the combination or the sum of addition of all the samples corresponding to a fixed value of material type and for all the 3 different temperatures. Then you have 1300, which is basically corresponding to type 2 material for all the 3 temperatures, and 1501 if you consider is basically for all the 3 temperatures for type 3 type of material, and obviously you have the averages values already written down. So, using the equations, one can find out the sum square of the totals comes out to be 77646.97. If I find out that of the material type, which is basically the so called factors which I have considered, so that comes out to be 10,683.72. For the temperature, which is the second factor, so if you remember A and B, so here consider A as the material, B as the temperature. So, SSB, which is for the temperature, comes out to be 39,118.72. And if I find out the interaction between the temperature and the material, the average comes out to be 9613.78. So, if you basically separately add them, these values of the sum of those, and in the sum of the square errors has also to be found out. So, the sum of the squares of the errors would technically be sum of total, which is this, which is here, minus S of A, which is only for factor A, which is given here as 390. Okay, sorry, my mistake. The 77.646 is here, which is sum total. 10,683.72 is basically for factor A. 39,118.72 is for factor B. So, and the value of the combination is 9,613.78, which is for A and B combined together, which is here. And if I find out the sum of the square of the errors, comes out to be 18,230.75. So, with this you can basically proceed for the next level, find out the mean squares, find out the f values and do the test accordingly. So, with this I will end the 17th lecture and continue more further discussion for the 18th and so on and so forth. Have a nice day and thank you very much for your attention.